This is an introduction to Numpy. These resources are available locally on GitHub or via the slides link. Numpy is a really powerful package that adds a lot of functionality when working with arrays and matrices for data science. And when you're doing mathematics with vectors or with matrices, this is really one of the packages that you're going to want to go to. Often when we're working with the Numpy package, we'll import it as MP with the abbreviation, so that you'll see when calling Numpy methods, you'll typically have the methods np dash whatever the method name is. So if we were to create a Numpy array, we can pass it a list, as in this example. So here we're passing it Numpy array. We can see at the output that this is class numpy.array. We can slice a Numpy array just like we could a list, selecting the first at index 0. We can select index 0 through 3 using a colon. We can select the second value to the end of the list by leaving the second space blank. We can print the last value with a -1 and print up until the second to last value with -2, just like we did with the list. There are a lot of functions that we can do with Numpy arrays. So we can set a Numpy array. We can use regular math terms to be able to multiply this array by 10. So that would multiply each value of the array by 10. If we wanted to use the embedded multiply function, we can pass it the two things that we want to multiply. One of them here is an array, the other is an integer 10. Similarly, we can add arrays using the regular functions that or mathematic terms that you would use in a calculator, as well as the embedded NumPy functions. And in each of these cases, you can see the resulting output here is printing and doing the calculations on each of the values within the array. NumPy has a variety of embedded functions to be able to create the types of arrays that you want. If you start off with the np.arrange, that will generate an array from 0 to 14 or 15 different numbers, sequential numbers. You can similarly pass 3 values to the arrange function with the start, stop, and end, delineating the characteristics of the array. So by default, it will be a start of 0 and a step of 1, so that if you omit those variables, it will default to them. We can then reshape the array to whatever matrix size that we want. So here we're shaping it to a 3x5 array. And if we would want to create an array filled with all ones, we can do that with the np.ones function, reshaping the function directly to a 3x5 array and specifying the data type as a float. Similarly, use the np zeros to create a 3x5 array full of zeros that's an integer type. We can use np full to create an array of all 4s. And so you can imagine if you wanted to have an array of all 4s, you could either use np full or create it with np1s and then multiply it by 4. We can also create arrays that involve decimals, and you can see in this example we've created an array that includes 0 to 1.5 with a step of 1, and then we've strung these two method calls together, then reshaping the array to a 3x5 array. So we can do this either through sequential calls of first np arrange and then reshape, or stringing them together as a single line. We can also generate random data with NumPy from specific distributions. When you are generating random data, it's also very useful to be able to generate that random data consistently, such that if you were to generate some random numbers from different students, those random numbers would be actually the same. And so we select or set the seed as a way of generating random numbers, but doing it in a consistent way. So that once we've set this seed, running these commands over and over will generate the same series of numbers. If you want to generate a different series of numbers, you just would have to generate a new seed. We also can combine arrays in a number of different ways. Here we first generate an array A, and we concatenate, which means extend the two values of the array into a single array. So here you can see 0, 1, 2, 3, 4 and 0, 1, 2, 3, 4 are concatenated together. We can similarly vertically stack the arrays, so one on top of the other, creating an array that has 2 rows and 5 columns. We can then take 2 of those same arrays and horizontally stack them together so that the resulting data set has 2 rows and 10 columns. And these types of functions are useful when splitting data, putting data of different groups back together, and generally parsing data sets in a variety of different ways. It's very useful to be able to slice arrays to get exactly the part of the array that we want. And NumPy has some great features for that. Here we can select the spot in the array where we want the array to start, stop, and then the steps to be used. By default, it will start at 0, end at the last value, and the step will be 1. If we wanted to print the entire array, and this is also important when creating a copy, we can specify just 2 colons to indicate the start and stop, and the step should default to the default. So in this case, we can first create an array that has 15 values, starting at 0, ending at 14, with steps up 1, and then slice that array in a variety of different ways. Here, starting at 2, ending at 9, stepping at 3. Again, remember that these are all indexed at starting at 0. Here we can print every other value in the array by setting the step to 2 and leaving the other values blank. We can similarly just indicate that the array should print between 2 and 9, leaving the step blank, and it will default then to 1. And we can also print all the array by including 2 colons as shown here. We can pull NumPy arrays from other data sets, and so here we've pulled the iris data set. If you're running this locally, it should work okay. We're using some things here that we haven't really talked about yet to be able to parse the data. Don't worry too much about that. We can see that the data is being pulled in as text fields. So because of this text field to the right here of the iris type, it's assuming that the rest of the data is also of text. And as a result, we've got to, if we want to utilize and work with this data, we've got to change it over to the correct numeric type, which is a float in this case. And so here we're selecting out a series of the NumPy data set that we want to work with. We're specifying the rows and then the columns using the notation that we used before to just specify the point in the array. And so here we're giving all the rows or all of the rows and just columns 1 through 4, or the index position 0 through index position 4. We're then changing the type, so we're calling as type and passing a float. You can see a variety of different types by going to the NumPy documentation, the links provided here. And then we can print the data and see that the data has been converted to a numeric type. Often it's very useful to be able to select a single column of an array and work with that to do different calculations. It could be data cleanup, could be other types of feature generation or other things. In this case, we're going to select out just the first column, or index position 0 to 1. So again, we're specifying the rows on the left side, columns on the right side, and generating a new variable here. And we can see that the resulting type is a NumPy array that we've indicated here. And we could do additional calculations such as summing the variables on just that one particular column as shown there. That's it for the lecture on NumPy arrays. There are a variety of different exercises here that should be relatively simple. You probably have the hang of it now after working with some of the different exercises in the previous notebooks, and see you very soon.